Application of oxidation reactions. So we have two applications of oxidation reaction. One is called as corrosion and second is rancidity. What is corrosion? It is a process in which metals are eaten up or degraded gradually by action of air, moisture or a chemical such as acids on their surface, resulting formation of compounds such as oxides, sulfides, carbonates, sulfate, etc. So these are the products which is formed on the surface of the metal. Let us see one example. Corrosion of iron, which is also called as rusting. So here we will see how this phenomena will take place on the surface of the iron. So here I have drawn one diagram. So this is a diagram of a metal surface. Metal means iron. So this is a diagram of iron in which this is a drop of water. So one drop of water is there, and this drop of water is not pure water. This is your impure water. Okay, so in this what happens, one CO2 gas can be fairly soluble in this water, and oxygen also can be soluble, easily soluble in this water. So this carbon dioxide plus water, it will combine to form carbonic acid, and carbonic acid undergo dissociation to form H plus and CO3 minus ions. Also, iron dissolves in the water to form Fe2 plus and 2 electrons. So they are giving electrons. So in other sides, oxygen takes hydrogen from the by carbonic acids and electron from the iron. So they will convert into water. So there is a two type of reactions undergoing in this systems. So this is a electrochemical process. So this process is oxidation and this process is reduction. This is a redox reaction, a phenomenon of redox reactions. So after taking this, so we have just written one reactions. So iron plus oxygen plus this one, H plus oxygen. Combine these two equations. So we will get Fe2 plus and water. So again this will further react with oxygen and they will finally form Fe2,3 oxide in aqueous form. So when you dry it, this will convert into Fe2,3O3 and X molecule of water. This is actually called as rust. So this is hydrated iron 3 oxides. So this is very important. It is very important for us to prevent the iron metal, because iron is the most abundant metal on our earth surface and it is available in the cheap form. So it is important to prevent these important metals. How to prevent it? So we can prevent by painting, by applying grease or oil, by tin plating or chromium plating. So we are making so many products like tiffin box, bicycle handles. They are usually done by the chromium plating. Chromium is less reactive than the iron. So whenever air will react, it will react. It cannot react with the chromium. Okay, so in this way iron is prevented. Even we can also make it by alloying it to make steel. So here iron, chromium, nickel and some traces of carbon also mixed with the major proportion of iron, and we make stainless steel. So here we can also prevent it. Another best method is the galvanizing method. In this method what we are doing, so we by dipping this iron in molten zinc, and the zinc layer is galvanized on the surface, is painted over the surface of the iron. Okay, one more method is electroplating. So of zinc by electroplating of iron by zinc through electrolysis. So through electrolysis, zinc is painted over the surface of the iron at atomic level. So in this, if you put one scratch over this galvanized iron, so whatever after scratching also iron cannot be wasted, and oxygen and zinc is more reactive than iron. So oxygen first react with the zinc. So in this way iron inside the zinc layer is prevented. So this is the best method for the prevention of the iron. Next we will see corrosion of aluminium. Second, corrosion. So corrosion of aluminium react with the oxygens, it will form aluminium oxides, and aluminium oxide is always found. Aluminium we never found pure state. We always found aluminium oxide in the state. So this is the surface of the wire of the aluminium. This is the wire of the aluminium. On the surface of the wire whole surface we get the oxide layer of aluminium. So in this way aluminium, inside aluminium is prevented by the natural way of corrosion. One more way is there in which we can prevent the aluminium also. That way is called as anodizing. ANODISING, anodizing. So it is a process of forming thick layer of aluminium oxide layer on an aluminium. So here in this layer of aluminium we are putting one more oxide layer by making it anode during the electrolysis of dilute sulfuric acid. So in dilute sulfuric acids, so what we are doing, this is dilute sulfuric acid. Here we are making anode. So this is your aluminium and this is your H2SO4, dilute H2SO4, and this is the another pure metal. So what happens, pure metal of aluminum. So what happens? This oxygen layer produced in the sulfuric acid is deposited on the surface of aluminum, and this makes this aluminum more thick layer, and in this way we can prevent this aluminum more by using anodizing layers. We can prevent it, more thick layer of aluminum oxide layer. Next is corrosion of copper. So copper, again, in presence of air, water, air means they contain CO2, they will form one compound called as basic copper carbonate, CuCO3 dot CuOH whole twice. This color is basic copper carbonate, color is green color, green coating. So usually in pipes or any copper vessel you are finding green color, means this has been corroded, means metal has been eaten up or destroyed. Next is corrosion of silver. So this is also called as tarnishing of silver. Tarnishing means corrosion. Oxidation, basically term is oxidation. So here aluminums react with the sulfide and moisture also required. So in presence of these two elements, these two compounds, they will give you silver sulfide and sulfur dioxide. Silver sulfide is black in color. So we can remove this tarnishing. How we can remove this tarnishing? So if you use the silver sulfide in aluminum foil using sodium bicarbonate solution and sodium chloride. So in this you take aluminum foil, you put these solutions and silver sulfide and you heat it. So what will happen? This sulfide from the silver will react with the aluminum and they will stick to the aluminum foil, and silver is present in the solutions. So after just separate the solution and again dry it, you will get silver back. Again, corrosion of gold and platinum, they are highly resistant to corrosion, but they dissolve in aqueous area, which concentration is concentrated HNO3 plus concentrated HCl in the 1:3 ratio. The reaction of this we will study in one other topic, metals and non-metals. Till now, thank you.